Linear inequalities. These are inequalities that we visualize with a number line. So I've mentioned that the goal of Algebra 1 is to find x, to find our number in disguise. Well, with linear inequalities, we're taking that kind of literally. We will literally find x on a number line. Okay, let me give you an example. Let's say x, our number in disguise, was 2. And we want to find that on a number line. So I have a number line here, and we want to find x. Where is x? X is 2, so let's shade in 2 on our number line. That is it. That's the goal. That's what we're trying to do in this video. Just finding x on a number line. And you can think of this number line as the x-axis. Remember with our linear equations, we had our x and y axis, x here and y up here, and then we'd draw a line. So we're just trying to think about this piece right here, this x-axis. So we're just going to think about that. So that's one way to think about it, or you can just think of it as a number line. Now let me give you another example. What if I said, I don't know what x is. Up here we thought x was equal to 2, but now I'm not really sure what it's equal to, but I know that x is bigger than 2, x is greater than 2. Well, how can I represent that on our number line? Well, before we shaded in 2, that's how we marked that x is here, but we're saying x is greater than 2, so it's not equal to 2. We know that. So what we do is we put an open circle around 2, saying that x is not equal to 2, but it is greater than 2. So we draw a line, the green line shading down the axis, and what we're trying to communicate with this is that x is somewhere in here. Up here, we knew x is right there, x is 2. But with an inequality, we're just saying that x is something bigger than 2, and we don't know what it is. But we know it's not 2, so we put an open circle to represent that. Okay. Well, what if I told you x was actually less than 2? How do we represent that? Well, similarly, we know it's not equal to 2, so we put an open circle, and then we mark everything less than 2. And we can draw that arrow just to say everything to the left is somewhere that x could be. X is just less than 2. All right. But what if I said x is less than 2? That's, I know that it could be less than 2, or x is equal to 2. It's one of those things. We know it could be equal to 2, or it could be less than 2. How do we mark that on our number line? Well, x could be equal to 2, that's what we're saying, so let's mark that with a shaded circle. Or it could be less than 2. So that's how we mark it, with that arrow. So again, we're trying to literally, as I mentioned up here, we're literally finding x on the number line. When we have x equals 2, that is an equation, an equality, and so we can just mark it with one dot. We know exactly where x is. But with an inequality, it's kind of like an area. We know that x is somewhere in a region. And if you see x is less than 2 or equal to 2, oftentimes in math we'll kind of condense that and just say x is less than or equal to 2. So that's the common notation. X is less than or equal to 2. Less than or equal. That's what that notation right there is saying. All right, let me give you another one. What if I said, and kind of think of it like you're a detective. You're a detective and you're looking for X on the number line, and I'm giving you some clues. So I'm telling you, I don't know what X is, but it could be greater than 2, or it could be exactly 2. So you're the detective. I'm giving you this clue. I'm telling you X could be 2, or it could be greater than 2. And your job is to plot that on this chart. So you say, okay, it could be equal to 2, or it could be greater than 2. So X could be somewhere there. You're looking for X, you're the detective, it's in this area. And similar to our above example up here, when we have X is greater than 2 or equal to 2, we condense that notation. We'll have, whoa, not like that. We'll have X is greater than or equal to 2. All right. So now that we've got an understanding of the basics, let's take it up a step. Solve x minus 2 is less than -1. And show the solution on a number line. All right, let's translate some of this stuff. So solve, that just means find x or get x by itself. Show the solution. Okay, that just means draw a picture, draw a number line, and you want to draw where x is. Draw the solution. Where is x? Okay, let's take it one step at a time. So if we have x minus 2 is less than -1. So in other problems, when we had linear equations, equalities, we would have something like x minus 2 equals -1. And we would do the same thing to both sides, right? We would add 2 just to get x by itself to both sides because it's an equality. We want to make sure we have the same thing on both sides. Well, how do we think about it with inequalities? Well, we've talked about this little picture where we have something that is bigger or smaller than something else. In this case, we have something smaller than something else. We don't know how big and small they are, right? We just know that something is smaller than something else. So, in a similar way, if we do something to one side, like add 2, we have to do it to both sides because we don't know how big and small they are. So we say, the left side, if we make this guy a little bit bigger, we have to make this guy a little bit bigger because we don't know how big or small they are. So as long as we do the same thing to both sides, we can be confident that the left is smaller than the right side. So we're doing the same thing as we did with equations, but now the thinking is a little bit different. We don't want to make sure that both sides are equal. We want to make sure that the left side is smaller than the right. And to make sure we do that, we have to do the same thing to both sides. So we maintain the inequality. And so now on the left side, we have x. And then we have that is less than -1 plus 2 is 1. Okay, so we just solved it. It said solve, which is get x by itself, and we did that. That is our answer. X is less than 1. It's smaller than 1. We don't know what it is, but that it's just smaller than 1. So let's put that on our number line. We're told to show the solution on a number line. So, well, we know x is less than 1. It's not equal to 1, so we draw an open circle, and we shade everywhere x could be. You're the detective, and you know that x is somewhere less than 1. And that's it. That is the answer. Let's try another example. We have negative 3x plus 4 is greater than negative 17. Okay, we're going to have the same idea. It's a little more messy of a problem, but same idea. We want to get x by itself. And to maintain this inequality, to make sure the left side is bigger than the right side, we always do the same thing to both sides because we don't know how much bigger the left side is, right? So as long as you do the same thing to both sides, you're good. Okay, let's subtract 4. All right, we can get rid of that 4. We get closer to getting x by itself. Then we're left with negative 3x is greater than negative 21. Now I want us to take a step back just for a second. So we have x, our number in disguise. So if x is a number in disguise, isn't 3 times x a number in disguise? If x is a number, any number, 3 times that is also a number. So let's just say it's some number in disguise. Let's just call this something. 3x is some number, something. We don't know what it is. And that means we're going to rewrite this equation as negative something is greater than negative 21. So we have negative something, some number, 3x, is greater than negative 21. So how can you get something by itself? Well, you would multiply or divide both sides by negative 1, just to get that negative out of there. So you're left with something is greater than 21. This is wrong. Why? You'd think this is right? We just followed our steps, and now we're left with an answer. And you think that there's nothing wrong with this. However, let's think about our number line and what we're doing. Okay, here's a number line. 0 is here, and we're going to start off by showing where negative something and negative 21 are on this number line. So negative something is bigger. It is, you owe something. Thinking about our money, we're owing something. We'd rather owe less money. So negative something is right here. Negative something. And negative 21 would be further on this side. Because as we translated this, owing something is better than owing 21. That's how we thought about it in our previous video, thinking about money. And that means we would put our negative something closer to 0, something that's less to pay off. Okay, so then we divided by negative 1, and we were left with this. Well, now we're not thinking about negative something and negative 21. We're thinking about positive something. So that would be on the exact opposite of the 0. So this is positive something and positive 21. So when you think about it, this negative 1 flips it over the 0. And now we're comparing two positive numbers. And so we have to flip the inequality sign. Because now something is less than 21. So that's an important concept that we need to keep in mind. When you multiply or divide by, or each side, remember, same thing to both sides. When you multiply or divide each side by a negative number, flip the inequality sign. Flip the inequality sign. And why is that? Because we flipped the two values that we're comparing to the other side of 0 on the number line. And because of this, instead of comparing two negatives, we are now comparing two positives. So negatives are a little tricky. It's something we need to always watch out for. So let's go back to our original equation. The reason I brought up this idea of something is just to explain this concept that we start off comparing two negative numbers, and once you multiply or divide each side by a negative value, you end up flipping it to considering two positive values. And so the comparison or our inequality changes. So let's go back to our original equation. I'm going to get this out of the way. All right. Okay, so we have negative 3x is greater than negative 21. We want to get x by itself, so we divide by negative 3. And because we're dividing by a negative number, we are going to flip the inequality sign because now we're comparing two positive numbers. And so the inequality flips, the comparison flips. So negative 21 divided by negative 3 is 7. That is our answer. And putting it on a number line, I'm going to need more numbers here, aren't I? Let's extend our number line just a bit. Okay. All right, you're the detective. You don't know what x is, but just that it is less than 7. Okay, so it's not equal to 7, so we'll put an open circle, and it's somewhere less than 7. So we'll draw a line and put that arrow, saying it can be anywhere to the left. And that is your answer.